Action.
Hello, and welcome. Oh, jeez. Oh, those lights are bright. Can we get these lights? Cut.
Cut!
Hello, and welcome to Channel 8 News, your local solar system news station. We'll be starting off with our rocky planets. Sending it to our rocky planets expert, Adam. Off to you, Adam.
Welcome to today's interplanetary weather report, where sunscreen is going to be useless and jackets won't help either. First up is Mercury. So on Mercury, temperatures can reach up to 431 degrees Celsius, but at night it can go as low as negative 180 degrees Celsius. This is because Mercury has little atmosphere, just a thin exosphere, meaning it can't trap or distribute heat. So this means that during the daytime, temperatures are going to rise, but when the sun isn't facing Mercury, temperatures are going to drop. Now let's head over to Venus, where the weather forecast is essentially the same every single day. Temperatures on Venus can reach about 464 degrees Celsius during the day or night, it doesn't matter. So unlike Mercury, Venus has an extremely thick atmosphere that's made out of mostly carbon dioxide. So when the heat gets trapped in this carbon dioxide, creating a runaway greenhouse effect. So when heat from the sun gets trapped, it can't escape, it turns Venus into a permanent pressurized cooker. So while Mercury has extreme temperatures because it has little atmosphere, Venus has extreme weather because it has too much of an atmosphere. Same neighborhood in the solar system, extremely different weather disasters. Back to
Ausdin.
you.
We come back to you with breaking news regarding the continuation of what some are calling the redout on Mars. We captured incredible footage of this terrible sandstorm. Here's the footage now.
Mars News Network. We're live in the Solis Habitat District where a Category 5 dust storm is making landfall. Winds are slamming into the settlement. That home behind me, Lot 12, was rated for moderate.
That is just terrible. As we continue to track that storm that's been going for weeks in the southern hemisphere of Mars, we'll give you an update on what the rest of the week looks like. As one of the biggest dust storms in about 3 Martian years continues to sweep through Mars, your weather outlook for this week does not look very promising. Our wild change in temperatures, as you can see, will continue, as that is what Sun of Mars does best. As you can see, your lows will get down to about the negative 80s, and your highs will remain in the single digits. And then continuing for the wind gusts this week will be around 30 to 60 miles per hour, so best to stay inside. Thanks for that Mars update. Here on Earth, everything is quite calm, much different than the rocky planets. Let's see what Will and Ausdin have for us in the Jovian planets.
Let's take a look at this week's weather on Jupiter. As always, on the solar system, its largest planet, conditions remain energetic and extreme. Jupiter has no solid surface and the atmosphere is driven primarily by internal heat, not sunlight. That means we're seeing constant motion, powerful jet streams, and long-lasting storms across the planet. Starting on Sunday, we're going to see high winds across much of the atmosphere, with high winds that are reaching hundreds of kilometers per hour. These winds are driven by Jupiter's fast rotation and strong east-west jet streams, and they show no signs of letting off. Moving into Monday, conditions become increasingly turbulent. Thick gas clouds made of ammonia and ammonium compounds are mixing rapidly, leading to unstable atmospheric flow. Visibility throughout the cloud tops become extremely limited, and travel through the region would be hazardous. By Tuesday, we're seeing major storm activity develop. Jupiter storms can last for months or even centuries, and some of these systems are large enough to engulf the entire planet of Earth. Lightning has been observed deep into Jupiter's atmosphere, so today's conditions reflect intense vertical motion in lower cloud layers. On Wednesday, we're going to see the winds intensify even further. Expect extremely windy conditions, especially near the boundaries between Jupiter's light-colored zones and darker belts. Wind speeds here can exceed 500 kilometers per hour, far stronger than most powerful hurricanes on Earth. On Thursday, it is a day to watch because, especially if you're on Jupiter's southern hemisphere, the Great Red Spot, a massive centuries-old storm, becomes the dominant feature. This enormous anticyclone produces some of the strongest winds on the planet, and nearby regions experience extreme turbulence as surrounding jet streams are pulled into the storm. Finally, on Friday, we're going to see conditions remain turbulent with thick cloud cover and ongoing atmospheric mixing. While the storms may shift slightly in position, they do not dissipate. Jupiter's weather systems are built to last. Throughout this week, temperatures remain steady at around negative 110 degrees Celsius at the cloud tops, and it's important to remember that pressure increases rapidly with depth, making Jupiter's deeper atmosphere increasingly hostile. In short, there are no calm days ahead, just another dynamic week of powerful winds, massive storms, and swirling gas clouds on Jupiter. Next, let's turn our attention to Saturn and take a look at the week ahead. Saturn's atmosphere, like Jupiter's, is made mostly of hydrogen and helium, but its weather has a noticeably different character. While Saturn may appear calmer from a distance, it actually has some of the fastest winds in the solar system, driven by both rapid rotation and internal heat. Starting on Sunday, conditions are hazy, with thick ammonia clouds dominating the upper atmosphere. Saturn's cloud layers are less visually distinct than Jupiter's, giving the planet its soft yellow appearance. Temperatures remain near negative 130 degrees Celsius, and there is no indication of surface-based weather, since Saturn, like Jupiter, has no solid ground. By Monday, atmospheric motion increases and we transition into turbulent conditions. Strong jet streams near the equator begin to intensify, with wind speeds capable of exceeding 1,600 kilometers per hour, faster than even Jupiter's winds, and far beyond anything we've seen on Earth. Moving into Tuesday and Wednesday, we see periods of partly cloudy conditions and banded cloud formations. Saturn's bands are more subtle than Jupiter's, but they still represent powerful east-west winds flowing at different speeds. These bands can shift slowly over time, leading to localized turbulence without dramatic daily changes. On Thursday and Friday, conditions briefly appear calmer, though it's important to note that calm on Saturn is still extremely windy by Earth standards. These periods reflect temporary stabilization in the upper atmosphere rather than an absence of motion. By Saturday, turbulence increases again as deeper atmospheric systems rise toward the cloud tops. While Saturn does not currently display a massive storm like Jupiter's Great Red Spot, it is known for producing rare but enormous storms like the Great White Spots, which can grow to encircle the entire planet and last for months. Throughout the entire week, Saturn continues to emit more energy than it receives from the Sun, partly due to helium rain occurring deep within the planet. This internal energy keeps Saturn's atmosphere active year-round, powering its extreme winds and long-lived weather patterns. In short, Saturn's week ahead features steady temperatures, powerful jet streams, subtle cloud bands, and persistent atmospheric motion. A quieter look than Jupiter, but no less extreme.
Thanks, Adam. Moving on to Uranus, one of the famous gas giants. Uranus has some of the strangest weather in our solar system. At first glance, Uranus looks pretty featureless, but I promise you, that is misleading. The planet's atmosphere is made up of mostly hydrogen, helium, and methane. Methane absorbs the red light, which gives Uranus its blue-green appearance. One of the biggest drivers of Uranus's weather is its extreme axial tilt of 98 degrees. Essentially, Uranus rotates on its side, which leads to extreme seasons where parts of the planet experience decades of sunlight or even decades of darkness. Despite receiving very little heat from the sun, Uranus still has very strong winds, reaching speeds of up to 500 miles an hour, which gives us a wind chill a little bit colder than negative 205 degrees Celsius. These winds drive large-scale atmospheric circulations, even though the planet gives off surprisingly little internal heat compared to some other gas giants. Storm activity on Uranus can increase dramatically around equinoxes when sunlight hits the planet more evenly. During these periods, scientists observed bright cloud features and storm features forming, showing that Uranus's atmosphere is far more active than it appears. Next, we move on to Neptune. Neptune, sitting a little farther out, has the most extreme weather of any planet in the solar system. Unlike Uranus, Neptune's atmosphere is made up of primarily hydrogen and helium with a little bit of methane, giving it its deep blue color. However, Neptune behaves very differently. Despite being further from the sun, Neptune has a much more active and violent atmosphere. Neptune is famous for having the fastest winds ever recorded on a planet with speeds exceeding 1,300 miles an hour. These winds drive massive storm systems, including the famous Great Dark Spot, which is similar in size to Earth, which was observed by Voyager 2. Unlike Uranus, Neptune gives off a significant amount of internal heat, which is a major driver in a lot of its weather. The internal energy fuels strong convection, leading to large storms and rapidly changing cloud patterns and intense atmospheric motion. Neptune's storms can appear and disappear and change shape in just a few years, making its atmosphere incredibly dynamic. Even though Neptune is extremely cold with temperatures around negative 350 degrees, its weather is anything but calm. Here's a little week of Neptune as we go across with a high of 7 degrees and a low of negative 201 degrees Celsius.
Thank you, Will and Austin. Phew. After hearing those updates, sure makes me glad to be here on Earth. Our solar system sure does sound dangerous. Alright, I think that's all we have for you today on Channel 8 News. Thank you for joining us on this lovely morning on Earth. Once again, we're Channel 8, your one-stop shop for solar system weather updates. In case I don't see you, good afternoon, good evening, and good night.